Hi chemistry students, I unfortunately can't be there today, so I wanted to give you a lesson on the Roman numerals. I know I showed this to all the sections of classes yesterday, but in case you weren't here or you're watching this remotely because you're away or home, due to being sick, I went ahead and started from the beginning of the topic. So what's going on is we're looking at doing naming ionic compounds containing, move this, if I can try to move this here, this recording item in here. So, okay, so we're going to be doing the same kind of things, but we're using the elements that are in the D block, like copper and silver and zinc, manganese, nickel, etc. All these are from the D block, okay? We are going to also do, this topic is also on tin and lead, and they're actually in the middle in group 14, but they're at the bottom of group 14, and I can visually show you that here. I'm going to flip over to that page. We'll come back to filling in the blanks here. You obviously can see them and fill them in, but if you get your periodic table with the type of predicted charges, this table that I've been showing you, having you use, please, if you haven't yet, complete the transition metal section here and label it using having +2 charge, but they also have a variety of charges. You're going to use Roman numerals. Everybody that's in this D block area that I've marked in this tan section, you're going to use Roman numerals. Now, it also involves tin and lead. Tin and lead are also going to be, they're actually right here and here, to be honest with you. I got in the wrong row, but tin and lead can be +2 and +4. So you're welcome to mark that on your paper here. Take a second to write this in and put this in your periodic table that has all the charges, okay? And we're going to be able to use that, as information, just like we do for group 1 and 2 and 13, and then groups 15 through 17. Just like we're doing those 6 columns, you're now going to be using the D block metals. Now we're going to use a Roman numeral. So in the actual note sheet, and in case, there's note sheet extra copies, left up by the front door of the room, or it's also going to be inside this section in the Schoology page that I'm making with this video. So, but we're using these notes, and we're going to go down and use these examples to talk about how to put the formulas together. And then we're going to go on the other side of the page to talk about how we're going to put the Roman numeral inside the name right here, inside the name, put a Roman numeral right inside the name. So I'm hoping to do a couple examples, maybe 4 examples on the back side, and possibly do about 4 or 5 examples. I've got a lot of the charges set up and typed up, but most of these I'm hoping to show here with you. Okay, now let's first talk about the actual blanks. I mentioned these maybe to period 2 yesterday or some of the sections, but if not, let me go over them with you. Roman numerals are used in naming of ionic compounds, and they're equal to the charge of a D block or transition metal. And that also includes tin and lead that are in the ionic compound. These metals in the middle of the periodic table do not always have the same charge, and they don't always lose the same number of electrons. So this Roman numeral can be several different numbers, okay? They equal the charge of the metal, but not the subscripts that's used in the formula, okay? And a lot of times with the ones we're doing here, we're going to be anywhere from 1 to 4. So that's I, II, like the copper 2 here. Copper 3 has 3 I's, and then if you're 4, you're IV. So these are from the Roman numerals. Hopefully you've heard about or known about over the years, okay? So we've got these that I mentioned: copper, silver, zinc, iron, titanium, lead, manganese, nickel, and tin. Here's a list here, but also on your polyatomic ion chart. We also have a list here, and I will try to stick to these when we're going to be using them on the unit tests this week. You might see a couple, you unique ones, maybe on the homework sheet that you have, and the this practice here, and then the new double-sided review practice page I'm giving out today too. So, but you can use this list and gives you an idea. Hey, mercury is only 2 possible charges, lead's only 2 possible charges, iron's 2 different possible charges, where gold is always +3, where silver is always +1. You know, some of them are exactly, and zinc's always +2. So this list is going to be helpful so you can pick between them, okay? Now let's go back and do some examples, okay, back on the page here. And we have copper 1 chloride, and we have copper 2 chloride. And again, that means copper is +1 here in this formula here. Copper is going to be +1 in this formula, but it's +2 in this formula, and that's why there's 2 chlorines in this second formula, okay? The +2 is the charge, and this 2 goes with chlorine just because chlorine is a minus. So when it's copper 2 chloride, you do have 2 chlorines, okay? Now, it's not always the number of the opposite element either. You have to figure it out, and I'll show you the math steps on the other side, okay? So on this side of the page, which I try to influence you guys to get written, at least write out the ion charges, is that these tell you what the charge of manganese, and the charge of iron, and the charge of this iron, and the charge of tin, and the charge of silver. So when you see that 4, then this means that you have manganese 4, as a charge, and then it's with oxygen, oxide, so you're going to have O2 minus, and you should know the charges based on the where oxygen's at, you know, being -2, but manganese is in the middle, and it can be various charges, okay? So when you do this, you're going to be balancing out a +2, a +4, and a -2. You have to make oxygen having more than 1. So it's going to be, and I have it all typed up here, it's going to turn into doubling the oxygen. We're going to double the oxygen to make it -4, and that's why you double the oxygen. Okay, so if you could write out the ions and charges, figure out the new formula. We could do it for zinc here. Zinc is +2 because of the Roman numeral 2. Chlorine is minus. You guys try to balance out the charges. We've got silver being 1. Because of the Roman numeral 1, and iodine being -1, and that's because of silver 1 iodide. You guys equal out the charges. That would probably be really simple there. We've got iron 2, so you're going to put as a Roman numeral 2 or +2, and then we've got carbonate -2, and so that's going to be really easy to put together and equal out because they're the same. We have iron 2, we have nitrate minus, okay? And so you're going to have to equal out the charges where iron is losing 2, and then the nitrate ion has N's and O's. With the overall setup of these 4 atoms, there's an extra electron. There's an extra electron there, okay? So this guy is taking 1, and this guy is losing 2, and they got to be equal. Okay, now the next 4, I went ahead and put little question marks because you guys should be able to figure out the charge with all these other examples. When you see a 2 there, you should know what the positive what for 10. And then on the periodic table, what is phosphide? Okay, you should find phosphide on the periodic table being in column 15. You know, being a certain charge for column 15 will be a -3. So for these final ones, I'm going to show a couple more answers here, but you fill in the charges. We have nickel, with it being with 3 I's. What's the charge of this nickel? What's the charge of sulfur, being based on where it's located on the periodic table, because it's just sulfur. Where this is nitrate, which is a polyatomic, this is the polyatomic ion, because it's nitrate. This is carbonate because it has the 8 endings, so you're going to have more than one. Got to go to the polyatomic ion list. Just like we had on the quiz yesterday. The only thing different is that you're using the Roman numeral, and all you got to do is balance out charges. Iron +2, carbonate -2, you basically put those guys together and you've got one of each. Okay, when you balance out zinc +2 and you have chloride minus, you notice the chloride has 7 dots. Remember that it has 7 dots. It wants to gain 1, where zinc is losing 2. So I've got to be doubling which one. And you guys should know which one am I going to be doubling. Okay. Well, it's going to be the chloride. So here is that answer, how you balance it out and write out the formula. Zinc Cl2 is zinc 2 chloride. Okay. But when it's plus and minus, we're going to put Ag and I together because they're 1 to 1. Okay. And then to finalize here, you're going to have copper with whatever charge it is and O with whatever charge it is. You guys figure out these last 4. Okay. Figure out what the formulas are based on their charges. Okay. I did fill in nitrate and iron. You guys try to fill out that formula and then try to finish these last 4. Okay. Now the other side is where a little bit harder, and I probably will help a little bit more tomorrow when I'm back in class. But when you do this, you're going to do, you see number 1 and number 2 are both copper oxide. But this copper has only 1 copper, but this copper has 2 coppers, and that makes a difference. It's going to make a different charge. So you are both going to be doing copper oxide for both. You're going to write those both in, okay? You're going to write in lead chloride. You're going to write in nickel bromide, you know, silver phosphate. You should know how to name all these, okay? It's just a matter of putting in what Roman numeral am I going to put in here? Am I going to put 1 or 2? You know, that's the question, okay? So there's a simple math equation that you're going to use, and you're going to look and see it here. Basically taking the total negative charges of all the nonmetals that you see there and dividing it by the number of metal atoms in the formula. That's all you have to do. So you're looking at the 1O oxygen or oxide. Oxide has a total charge, and there's only one of them. There's only one oxygen. So it's going to be a -2. Oh, sorry. I don't need to move that up. You're going to have a -2 here. And I'm trying to make it look like, I thought this was going to work out when I set it up. So we have, let me just go ahead and underline this to represent the line, the division line, okay? So this part is the top of the denominator. You're going to be doing fractions, so I'm going to underline this. This is part of your top of your fraction. So it's -2 because it's only 1 oxygen, and right here there's only 1 copper in the formula. So you're going to put 2 over 1 here. And I don't mean to underline it. I'm sorry about this format, but basically it's showing 2 over 1. And when you look at this, you're basically looking like this. I'm sorry, I'm trying to use, back that up. I'm trying to use the dark marker. Hold on. 1 second here. So you're basically looking at 2 over 1, and you don't worry about the charge. Don't worry about the negative charge. Just totally eliminate it. So that means overall this equals 2. This is the Roman numeral 2 because 2 over 1. So you're going to put in Roman numeral 2 oxide because it is -2 over 1 copper. And so you really just look at, you can even put the 1 copper there if you want. Move these around. I'm working from my keyboard and not at the smart board while I'm doing this and taping this. So that's why it's not coming out very well. But this is a 1. This is 1 copper. This is 1 copper here. So I'm putting the 1 copper on the bottom. And then it's basically trying to show you, hey, what is 2 over 1? Now again, don't worry about this minus sign. Don't worry about it being -2. Just ignore that. You can even take it out like that and basically see 2 charges of negative charges over 1 copper. Okay? Now on the other one, the next one on number 2, okay, let's move this over here so it's out of the way. I want to show the other one for question number 2. Okay? Now we're going to use, let me get rid of this because it didn't work out the way I had it set up. But we're going to use the fact that we have, still again, we have only one oxygen. We only have one oxygen, only one of them. So we're going to be a 2 charge. Okay, we're going to have a 2 charge, and we're going to put it over so many different coppers that we have. So I'm going to underline this to make it look like it's a fraction. Okay, so we have 2 over, and this time we have 2 coppers. The coppers, there's 2 of them. There's a little 2 right there, the subscript. So we're going to say that we have 2 over 2 coppers this time. And I don't want to change this. Sorry about these little mistakes. I'm just trying to work from the keyboard right here in the room. So basically now it's 2. It's totally 2 over 2. And if you look at 2 over 2, what does that give you? Kind of like look at the actual, look at the overall, what's 2 over 2 equal? Okay, the fact that there's 2 negatives over 2 coppers, that equals 1. That equals 1. So this time, this formula, when you have 2 coppers, you're going to be copper 1 oxide. Okay, because you have 2 negatives, is 2 on top, is 2 negatives. You don't even worry about the negative, its sign, but it's over 2 coppers. So that 2 over 2, ignoring the negative altogether, it's going to equal to 1. Okay, so it is kind of complicated, but I want you to try it. And you basically want to look at the total negative of this right here. I'm going to try to use a pen here. What's the total negative of 4 chlorides? And you're going to put that total negative charge over only 1 lead. And that will tell you what the charge of lead is. Okay? What's the total negative charge of 2 bromines over 1 nickel? Okay, and you're going to do the math to figure out what it is. And you also want to write in, I'm sorry, reverse that right real quick. That was a mistake. Okay, you basically want to type in, hey, the name, nickel, something, bromide. Okay, and the fact that there are two bromines over only 1 copper, you're basically putting 2 over 1. I'm handwriting that with the mouse. It's really bad, but that means 2 over 1. That means I'm going to put the Roman numeral 2 right here. I'm going to put Roman numeral 2. So it's going to be nickel 2 bromide. Okay? So you try some more of them out. Even when you do number 7 and 8, you both are going to use iron sulfide for both 7 and for 8. And you guys want to figure out what the Roman numeral is. Okay, so you try these out, and then I will also post the answer key on this same page in Schoology, so you guys can check your answers afterwards. I was going to set up and do some more of these bottom two, but I think I want to end the video now. Okay, but I've got a couple examples here between the copper 2 oxide and the copper 1 oxide, and even the nickel 2 bromide. They're all done for you. You guys try out number 3, 4, 5, 6, 7, and 8. And see what you get, and check out the answer key that's posted in Schoology. Okay? So, I hope this works out. Please let me know your questions when I get back. Okay? See you later.